many strengths and all. It will be refined more. This there will be RAM slide also couple of. So I will improve this one. Actually,
I just introduced Dr. Sanjay Kumar Sharma. He is the chairperson of our Center Brain Rapid Alternative Energy Mobility. And together we are working on the thing. I have already introduced him. Thank you, sir, for being over here.
it will be refined for this. There will be RAM slide also.
Dr. Neeta is also there. Dr. Neeta, I request you that while the presentation is going on the chairperson we can collect these questions rapid for the panel. And together we are working on the we can collect these questions on chat room. Thank you, sir, for being over here. Our next presenter is Rajesh Mishra has already given his presentation on 9. I request Professor S.K. Chaturvedi, sir, to kindly present, give his presentation and his topic on RAEMS.
Okay, let me try because I was not expecting this, frankly speaking.
So if you can just tell us, so if you just give us a brief about the presentation. That's
right. I'm just a second. Can you see something on the screen? My slides? No.
No, sir.
I'm facing the same problem Professor Uday is facing.
Sir, you have to go to the taskbar.
Yes. Present now.
उसमें स्क्रीन आएगा, उसमें एंटायर स्क्रीन के बाद एक विंडो ओपन होगा आपके स्क्रीन के ऊपर. उस पे क्लिक करके शेयर नाउ करना. उस पे भी क्लिक करना है स्क्रीन के बीच में एंड देन शेयर.
But share is not highlighted. Problem is this.
Share will be highlighted once you click on that screen जो बीच में विंडो आया उसके बीच में आपको क्लिक करना है.
I have clicked. Okay.
And then share will be activated. Yes, your presentation has started now, sir. Now we can see your screen.
Okay, just a minute.
So we can see your screen.
Yes.
System.
Now it is okay. It is full screen now.
Yes, sir.
Okay.
Yes, fine, sir.
So they has given a brief introduction to his institute, what they are doing, and they they are doing great research. Briefly, I'll say that I'm representing here Subir Chaudhary Schools of Quality and Reliability. What's Reliability Engine Center, created and propounded by Professor K. Mishra, and Professor there is knowing, everybody is knowing Professor K. Mishra's name. So here we are basically doing the research and the education at the level of MTech. We don't have any BTech courses. Certain electives are floated for the BTech students. And we are also doing the consultancy project and research projects for different organizations. And we take the intakes from, there is a GATE examination, which is conducted by centrally IITs. And the PhD scholars we choose either through interview, which is known as Institute Scholars, and from the sponsored candidate, both at MTech and PhD level. So we are 5 faculty members right now, representing different areas. You can say reliability is known to be interdisciplinary in nature. So one is from mechanical, another is from electronics, I am from electrical, and so on. So there are 5 faculty members rated by, and we have around 28 students in all first year, second year. So with this briefing, in this lecture or webinar, you can say that my lecture will be in 2 parts. Part 1 is related to the system effectiveness and reliability engineering. Briefly, it takes about the historically how it can be related with the RAEMS. Currently, we are using it. And another is, in most of the time, once we did some projects, very either they are talking about the MTP or MTTF figures, or they are, once we are asking that whether you have say set some goals to reliability, then they are not aware of. So basically, so this presentation it gives an idea about the various terms and terminology, and what will be the consequences if somebody is not creating the reliability figure appropriately and simply believing on MTF, what it will do. So with this, the part one is system effectiveness and reliability checking. So if you see that, what is system effectiveness? Is it RAMS also? So if you look at the historical background, then you will find that it has its beginning very early 60s. You can say post Second World War II. So major pioneering efforts was given by Wisiak and Arendt. Arendt is well known in reliability engineering area. They have propounded several methods for reliability, and they have done various researches in reliability areas. So the first one involved with the totality of requirement associated with the system's capability. Capability, in fact, initially the definition of reliability says that capability of a system, then it was later quantified using a property theory or so. So capability, availability, supportability, dependability, if you see that, as well as reliability. And reliability is a component of availability. And supportability again becomes a component of maintainability. And you recently, say 4 or 5 years, you started seeing that the word dependability, and nowadays performability. So the reliability, yes. So they rightly said reliability is becoming a component of that, definitely. But reliability can achieve many more things. So they published around 6 reports, but ARINC, which was established in 1929, is providing a solution to transport communication system engineering to different types of industry like aviation, airport, defense, healthcare, and so on. And they have given a very picture of reliability engineering in terms of overall this system effectiveness, which is encompassing this RAMS parameter as well. Well, so if you see what the picture have they given, system effectiveness. So so everything is measured. System effectiveness is also measured in terms of the probabilistic. It becomes a probabilistic measure, probability, because of it is dealing with various uncertainty. Mission reliability is, if you mathematically see that, it can be a product of three components: mission reliability, operational readiness, design adequacy. So if you see that, design adequacy is, so this is, you can say, the definition. The system can successfully meet an operational demand. Then this becomes a system effectiveness. It can also be said there is a technical system effectiveness and operational system effectiveness. There is another category. It depends on how you define the system effectiveness. If you are totally concerned with the inherent design based, then it becomes a technical system effectiveness. Where if you see the utilization characteristics like maintenance, etc., you add, then it becomes operational system effectiveness. So it is a probabilistic measure. So design adequacy, if you see that, it is the design, the system will successfully accomplish its mission. And on the design objectives, if you recently see that there was a ISRO mission where they said our mission was 95% successful. So I can say that becomes a design adequacy. It was such a good performance of design to objective 5%. Likewise, mission reliability is well known. You will find that the definition of reliability in various texts. But if you see that, the difference, you will find that the system will operate in the mode for which it was designed. And given that it was operating in this mode at the start of the mission, that is, the mission is going to be completed without any malfunctioning of the system. So the third part, operational readiness, has various components. So, so if you see that in a storage, idle or free state of the system, then comes the availability. In storage implies the system is presumed to be in operational readiness state. Whereas idle or free state, you can say that that system is operational, but it is not used for the purpose. And availability, so this is so storage time, you can say that is the time that system is presumed to be in operable state, but it is in, you can say in standby mode, or you can say at a spare, it is going to be utilized. The free time, operational use of the system is not required, but it does anytime it can be put into operation. And the operational readiness, the third component, availability. If you say that the availability encompasses, I'm not going to the definition part of that, but depending on the time components you incorporate, different types of availability definition you will find in the literature also, the textbook also. So in fact, any downtime, if you say active downtime time only, or you incorporate logistic delays also and other types of downtime also. So availability definition differs. So the availability, the major downtime you will see, or major time component which you will see are the operating time and the downtime. So ratio of this operating time divided by total downtime plus operating time will give you the availability definition. It depends on what downtime you are going to consider. Okay. So, so these are some of the, if you see the figure, if you see this diagram, you will see the reliability, availability, maintainability, RAM is coming. So system effectiveness is going to encompassing the RAM's parameter also. So these are some of the definition which is I am not stating those, except that these are the major components and these are the major definition which sometimes confuses the customer or the people who want to do the reliability study or any study related to reliability, availability. They confuse us with the various type of definitions. Right. So, okay. So these are some of the. So now those briefly I say, what is reliability engineering? So reliability engineering, it provides the theoretical and practical tools whereby we can quantify the capability of an item in terms of probabilistic measure, probability or chance. So this reliability just not become the definition, but it can be specified, it can be allocated and designed into the system when system designing begins, and it can also be predicted before we actually create the system or the item under consideration. It can further be tested. There are reliability testing, there are reliability testing methods, and through those tested, it can be estimated and predicted. In the sense, I am again using the predicted word because many of the times you go for the acceleration of the failure, so that you can have the data at the accelerated conditions of, and then you try to predict the performance of a system on the normal use condition. It can also be how the reliability grows. It can also be monitored, and it can also be demonstrated to the customer that yes, we meet the reliability goals, reliability target with their maintainability, availability, safety, and quality level in an optimized way. So this we try to cover in reliability engineering. So why reliability engineering? If you see that, particularly on the top, NASA government documents now require that reliability and maintainability clauses and its specification, and that should be properly understood. Once you are a bidder or you want to create a system, those terminology has to be understood very well, interpreted correctly to successfully bid and execute. Further, the complexity of the products. You know that today's our quest for excellence is creating a very complex system which have multiple functionality. So high reliability have to be designed and built into those piece part of the components. Now, people, you will find many of the products are being advertised by the reliability and maintainability rating, forcing a competitor to know the RM of their product. Unless a competitor knows the terms and terminology of those reliability parameters, how can he compete? And he is going to find out to generate such data for their own products. Learn how to quantify them and how to interpret those rating by for their own products. So these are certain of the reasons, and this gives uh, this comes to the benefits what we get from many customers have learned their benefits of reliability analysis from experience, and they want that whatever they are buying, whatever their supplier must have an effective reliability program. And this becomes our customer requirements. Customer is going to believe you once he finds that your system is going to last for the purpose he is wanting, and there are not much irritative failures which can cause customer discomfort. Another concerted effort towards improved reliability shows that a distinct customer that a manufacturer is serious about their product. So it's kind of belief between the customer and the supplier, and this gives the repeat business. So once a customer is satisfied with a certain product, he is also satisfied with the supplier also. So a repeat business is going to happen. And many of the companies you will find that predicting their publishing their predicted liability figures. So they are going to get an advantage over their competitors who either do not know what the terms are or do not publish their numbers or have lower numbers. So this gives competitive advantage. Another is warranty cost, because many of the time because of the time constraint or certain homework which has not been completed by the manufacturer, they try to give a warranty for their products. So if they are providing warranty, longer warranty means they will have the cost of the product is going to be high because nothing is coming to free. If it is giving you the warranty, they are definitely adding the cost of warranty of that. But they are through reliability analysis or any analysis which gives an indication that what should be the period through which the product is expected to fail more and what percentage is going to fail, so they can provide a warranty, and the company or the supplier is going to be prepared for meeting such demands. So warranty cost is, and others benefits which you will get, the reputation of the company, they grows once the, the, the customer starts believing, and definitely the customer satisfaction. Uh, the statement, what I say, that reliable product may not dramatically affect customer satisfaction in a positive manner, but a reliable product will negatively affect customer satisfaction. Similarly, it can take away another 10 customers from the company's database. So many of the times people question if quality does the same, but I'm just posing this question: can quality do the same? Possibly not, because it is again a debatable question. It will take another, because people of quality paradigm and the reliability type paradigm always on the two platform putting their positive points to quality is a subset of reliability, or reliability is a subset of quality. But what I briefly say, whichever gives the system robust enough to fulfill the purpose, that is you follow. If your quality is providing, I don't see any reason to follow reliability rules. So quality and reliability briefly, I'll say the customer frequently use the term quality and reliability, and that is one of the points where one should understand what is the meaning, what customer means by this quality or reliability, because people vaguely use these terms quality and reliability. If you see that quality label, generally measured in terms of different labels such as ppm, whereas reliability, if you see that, this quality becomes one kind of static. Now, reliability can be considered as quality over time. This is one of the statements you'll find find in many aspects. If you measure the quality with respect to time, then you are talking about reliability only. So talk about reliability, how this is measured, it is generally related to the failure rates, number of failures, warranty cost, and some life, D10 life or BX life, and so on. So the reliability is experienced by the customer when they use the product. This is possibly not true with the quality. Quality, reliability, and safety. The fourth term, which is RAMS. So safety, the quality defects and failures both can. So whether it is quality-related defects or the reliability-related failures, both can adversely affect safety of user. Some quality defect can lead to unreliable and unsafe project, where some of the examples you can see that affect reliability. On day-to-day basis, you can observe that failure if the automobile steering system or the brake system or any system of the automobile fails, will happen. On the electrical side, you will find electrical short circuited because so there are other examples. However, all failures are not safety issues, and all safety issues are not due to failures. You find on the net also, once you talked about reliability, availability, maintainability, and safety, you find the intersecting point. Just if you draw the Venn diagram kind of thing, you find some intersection. So there are some disjointed causes of failures which can be which can cause the safety issues otherwise, but the reliability, if you see the failure-free operation, things are not failing, possibly the safety issues will not arise. Reliability role in product development. If you see that, just see this figure. During the product development cycle of marketing surveys, then the design and development is started, and design and development has several stages, and then finally it goes to the manufacturing, and finally it goes to the customer, and the customer finds what were the requirements, and it was not meeting out. So it's a kind of all the over the wall approach where all the four walls are created and nobody is communicating in a manner to satisfy the customer. So this is the conventional approach followed by earlier. So reliability experts say that about 60 to 70% of reliability depends on design. And design and engineering function must therefore work with all these. These four walls must be narrowed down so that each one is communicative enough to get a solution for which the system is going to be designed and customer should be satisfied. So many of the tools technique you will find in reliability engineering are taught to the engineers or the prospective engineers and practitioners. So you will find that FMEA, FTA, HAZAR, and the reliability modeling technique and analysis techniques, everything else. Such kind of topics are going to be generally covered in reliability engineering. This is one of the important slide. You can say that, like any other programs, top management support is essential. Any of the time, if you talk to any reliability engineer, reliability HR, so you will find this is one of the bottleneck the reliability engineer faces while doing or practicing the reliability. So if you're very concerned with the reliability related study, if you are not having the top management support, possibly you will remain there where you are. So the role becomes the providing adequate and appropriate resources for reliability. Still requires commitment from there finding for the last 4 or 5 years, we are getting also the private companies also. They want to conduct reliability studies. So possibly the reason could be the concept of evaluating MTRM. This is not valid any longer. Because initially it was the risk assessment was solely responsibility by the customer. But nowadays this strategy is not valid. A product failure results into the loss of liability to someone, the company becomes liable. So a company is liable for its product, legally responsible for products. Secondly, recent standards are going towards absolute liability. Absolute liability, it means that even a person, a designer, a company head can be liable to, to bear the damages because of any failure and the consequences uh, of that. So, considering consequences and liability of failure, it is important to establish liability acceptance pool that will minimize and limit the events of failure. So, there are various techniques which are available in reliability. So, this is about the part one. So the next part I took it reliability specification. What should be how we can specify the reliability specifications.
Sir,
So reliability in design, it is yes,
I'm
yes.
interrupting in between, but then so the time limit is over for 25 minutes. So you'll have to curtail it because otherwise our whole webinar will, because everybody, we all will be taking 5-10 minutes extra, and then everything will go in.
Okay.
So we'll have,
So
the purpose of the dry run was that we
okay.
can define the limits and everything.
Yes, I said I am trying to
I know.
confine it
I
to
had a
20
discussion. I had a discussion with him yesterday.
Yeah, because I'll be leaving 5 to what is 6:30. I have to have another engagement, so I have to leave. I can't
Okay,
stay
okay.
20 minutes more.
Okay. So I'll try to see that how many slides I can tail down. Otherwise, I'll switch over to the. I will stick to part two only. Okay, not to part one. Okay, I'll try to stick to part two only, which is basically related to. I briefly show you. This is basically related to how the design process and where the reliability goals are decided. Okay, so this is a definition which is usually not found in many textbooks. You will find that the reliability definition something like that, and some conditions like mission time and under the stated condition of use. But the overall of definition is nothing but everything conditional and given on certain criteria, right? So this is related to the, how to what will happen once somebody develops the reliability goals are not like this. A new product will have a reliability that is no worse than that of the previous model. So this is if there is no quantification information about the previous model, what to be done, what is worse, what is good. Another is the product will meet or exceed customer expectations. Again, it is a very vague criteria. But problem is these are put into either advertently or inadvertently in the reliability specifications, which is not the correct way. So the essential elements of reliability requirement should be measurable. It has a desired confidence level and customer usage operating environment, and at least it should have one specified reliability, the time and desired confidence level. Based on that, okay, I'll skip this slide because failure definition is a must. There are various failure criteria, there are elements also, which is generally you'll find once you discuss the failure criteria is hard to get from the. Um, so I will skip this slide. So this is just to give you an idea how one can find out how to give a targeted reliability for a system.
Sir, there is a registration. There are 2-3 people who want to understand the how do we calculate the cost of the reliability, because they have mentioned in the registration form. So if you can concentrate on method 1 and 2, like, because
Well,
this will be quite relevant.
No, this is not related to that cost of reliability. This is related to how to set a target reliability for a given system,
Yes,
right?
yes, sir.
So generally, people are say, if you ask anybody what is, once you do any reliability study, they will say we have not set any reliability. Okay. So there are some methods. For instance, the third method is very easy, right? This one. Any one of the previous two methods cannot be measured, then you set the reliability system in excess of 85, preferably 90%, and accordingly subsystems are divided. So this is, in fact, 3-4 examples through which one can understand why reliability or why MTBF or MTTF is not going to be valid measure, or one cannot design with the given MTTF the system. So it can give you a wrong signal once a designer say I have designed for MTTF to 10,000 miles so, and still the reliability targets have been made, or there are more failures at the beginning. Right. So this is some examples. Okay. I know that there are many slides which, okay, so it is related to more on theoretical aspects, but the applicability is definitely there. So, Dr. Vidishi, I will keep this. I'll try to see whether how much I can reduce the slides.
Sir, I
Okay.
think the part 1, some part can be reduced because this part is quite relevant. Those methods and all.
So I
This
was
is
just
my
in a,
suggestion. That is
and
fine.
yes,
I
in
just
fact,
know the yeah.
in fact, I was in a double state of mind whether to keep part one, part two, because, but seeing the time, so I know that it can be, because there are around 54, 55 slides. Possibly they cannot be covered in 20 or 25 minutes.
I think Mishra sir has already sent you his slides.
Okay, I did not receive yet. Okay, I'll see that. Right. So
Because he's discussing the bathtub curve over there.
okay, I'm not say giving any bar but that's why, right? Because I find that the initial terms and terminology is taken by Dr. Rajesh, so I thought I will not put part. But right.
Sir, but you must cover the theory part also. Professor Rajesh is doing, and we are kind of we are looking towards you to tell us something about your theory. Only the time period has to be compressed, but otherwise, please try to cover as much as you can, sir. Please.
And so, in fact, I was thinking that I'll say that I'll cover,
Yes, sir.
and whenever the time gets over 25 minutes, I will stop.
No, sir. That will be wrong. We'll all be in suspense.
Professor Chaturvedi, focus on the
Yes.
roadmap, how you are calculating, demonstrate with example, that will be useful for them. And keep
Which
it within
one?
that. Just keep how you are calculating. That's very important for the participants to see how you are really calculating your reliability and all.
Yes, sir. Yes.
No, the thing is that if I see the participant,
Yeah.
possibly how to compute the reliability, most of the people are knowing. Because
No, but critical. Like a
Sir, railways, there is very less. There is no exposure to reliability engineering at all. Zero.
that's why I am saying the first is they don't have any exposure to how to give a figure of reliability, isn't it?
We don't.
So if
We
you
don't.
see, but right, we did a project in DLW, and they wanted to have empty figure. We are also doing several projects in defense. So you find they just say MTTF figure they just said, right. L&T company gave, he said, we want MTTF of our system, and they want it within 15 days.
So actually, Professor Chaturvedi, let us listen to Dhananjay. He is working with defense and defense industry, how they calculate the reliability. And maybe you can provide a more detailed theoretical background on that.
Yes, yes, yes. Definitely.
Yeah. But it's interesting what you are talking is very useful actually. But time limits and how to tell the
I know that.
in time.
Yes.
That's a challenge.
Definitely.
Anirudh sir, I request to have another the part 2 webinar also, because
Right. In that we can cover. Initially, I just wanted to convey
because we
that.
can't miss on any of these concepts. Those who are interested in part 1, those who are interested in knowing more, they can be incorporated in part 2 webinar.
Yes,
And
later it can be taken. Like I can take, I take usually the data analysis part. So what Professor Uday said, statistically, that is for new system, because they are not failing. Yes, that is another research issue. But whatever we have,
Actually, I was going to, today I couldn't do it, but I will be highlighting the challenges. What are the challenges,
Right.
industry challenges, and how to meet. And maybe you, Dhananjay is working with this, I know, helicopter kit reliability.
Yeah, I was listening very with great interest that how I am using all these theories. It was really good for me to listen this.
so my idea is then I'll see that what can I can cover in 20-25 minutes, right?
Yes, sir. 25 minutes, sir. You must keep 25 minutes.
Right. I'll try to see that how to curtail it down.
Sir, just try to give some ideas to the people without omitting anything. Just give an idea, and then the rest of the people, because we are planning a certification course for 4 months from September to December. So we will tell them that if you want to study more, and there are very much people interested. Vidushi was telling even people from Korea and other foreign countries are interested in our master's online program for the RAEMS and PHM. So we are getting very good response. Vidushi, I think 600 plus people have registered, is it?
yes, sir. Yes, sir. 610. Actually, 615.
The thing is that for such, I think for such query we can answer during the question hour or so.
Yes, sir.
You can, I think, Dr. Vidushi and Dr. Gautam, I will be thankful if you could get some idea of what type of audiences are there. The variations, like a starter and to the experts. So, because we should know a little bit feeling of the audience, so we can, who are the participants. Otherwise, I need to know little bit, some summary.
We will
In fact, I tell you, I just went through first 150 participants. I find that they are from the industry side also. They are also from the educational institute side also. There are many practicing engineers who are working in E-Town, Alstom, and so.
Yes, sir. Yes, sir.
So it's a wide cluster of different types of people who are participating in this one.
We are having a very wide variety, but we'll make a profile of the audience. Just condense it into various forms, and then because we've also taken the educational qualification of the audience, most of them are BTech, but some of them are MTechs and PhDs also.
Right. Even some are already reliability engineers.
Dr. Gautam,
Correct.
Sir, I'll be sharing you the whole profile details. I'll do the analysis of the data, and I'll be sharing the whole detail of what percentage contribution is of people from railways, what is the percentage contribution from academics and all. I think by tomorrow I'll be able to send each one of you.
You put it on the WhatsApp group, so everybody will get it.
Sure, sir.
Kindly
Sure,
let
sir.
us start. So we can finish in time. Shall we start now?
Yes,
Who is
sir.
the
Please,
next? Because I
let us welcome Dr. Dhananjay Kumar, and so that we can finish on time.
Thanks.
Thank you. Could you please unshare? Yeah, thank you.
Vidushi, is everybody's voice audible today? Because that day there was some problem with my voice.
Today it is very clear. Everybody is very clear.
Okay, so that is a boon, I think, today.
I'm doing the share your entire screen and then it is not highlighted, this share button.
Sir, if you see that there is a screen which comes on your window, on that window you have to click and then press the share again.
In the window itself.
Yes, you have to click the window itself.
You see all the pictures.
And then you put the share. First you go to the present now, share the entire screen, a pop-up window will come. You click on
Yeah.
that pop-up window and
Now it's going to work.
Okay, now, maybe we should issue an instruction for us. So we know exactly.
I think we have please put that.
Are you able to see my screen?
Yeah, now it's coming.
now we can see a screen, sir.
Great. Thank you. It was very interesting to listen to, especially Professor Chaturvedi and Dr. Uday Kumar. My background has been for the last 25 years applying these reliability calculations, methods, tools, management in the industrial applications, starting from telecom, defense industry, medical industry, manufacturing industry. So, yeah, so that's why I was finding very interesting your presentation. Now, coming back to, in my presentation, I would look into the whole life cycle of a product or of a system, starting from the concept phase till you declare the end of life of that system. What are the main key activities as per the reliability to maintain a good reliability of that product or system or process? And what are the practical challenges that we face when we are applying these methods? I'm audible to you all?
Yes, sir.
Yes, audible.
I'm not seeing the screen. Can you?
In fact, screen is not visible. It is just showing you are presenting to everyone.
But
And,
what is
not a screen.
Sir, you need to click on your PowerPoint tab.
PowerPoint? Click on PowerPoint, your presentation itself.
Is it visible now?
No? Put on your PowerPoint, bring your PowerPoint and click there.
Yeah, I did share my screen and then
Yeah, now you are presenting.
it says you are presenting.
Sir, then run your PowerPoint.
Just click your PowerPoint, sir.
Yeah, I'm clicking on my PowerPoint.
It open on your screen.
Yeah, it is on my screen.
Then everybody will see it, sir.
Okay. I'm just stopping the presentation
No,
again.
no,
and
yes,
trying
sir.
again then.
It was coming. Just now it will start coming.
I'm doing entire screen.
First, start we are not seeing your presentation.
Then I'm
Yeah, now it's coming.
Now we can see.
Now it is coming, yeah.
It has come,
Started.
sir. It has come.
Second one you are there. First one is full screen. Slides, yeah. Then you have
do you see the size okay or you? Is it visible now?
Size is fine, sir.
Should I go in slide mode?
Yes, sir.
Yes.
So
Now it is fine, sir.
hopefully you are able to see this reliability assurance road map.
Yeah, start with the first slide. You had something on the first slide also. You can see the
That's 2 slides then.
number one, slide number one. Yeah. Okay. That was the right. Okay. Yeah.
So in slide 1 is just the topic headline, and the idea of the concept of this presentation is to cover the product starting from the concept phase till we come to the end of the life of that product, system or process. What are the main activities during this roadmap and what are the challenges and issues that we face? And this is based on my applying this reliability methods, tools, or RAMs in industrial applications, whether it is a telecom industry, medical industry, defense industry, and manufacturing plants, and consumer electronics industry. So, starting from the concept is, that's where most of the industry, they don't take into account reliability requirements other than regulated industries. So most of the defense industry, they're very good in asking some reliability during the contract phase itself, like before the concept phase. But in commercial industry, medical devices or telecom industry, you don't have any reliability requirements defined. So I will cover a few things, like what are the challenges there. And then in general, next step becomes to predict the reliability of the design that we are proposing, or we are going to create a system. What the likelihood of getting the reliability of that specific system. Once we move away from these two steps, then comes design for reliability and the reliability demonstration. Either you do the demonstration by the testing or by the trials based on what is the requirement of the customer or how confident you are about your product. So especially whenever you have a new technology, new design, new configuration, new architecture, we go for the test. If it is an iterative design or evolutionary design from the previous generation to the next generation, depending on what are the changes, we define our test or trials accordingly to build our confidence in reliability of that system. And then it goes in the iterative process till we get a good confidence, then you launch your product or bring the system into operations. And that's where the major challenge comes from the commercial industry, that no one cares about that. They assume that the reliability will be all right. There is no much reliability investigation till something drastic negative happens. And in commercial industry, what happens in work-wise, the project team that is working on this system, developing that system or product, they move away to the another product. This becomes a low priority. And then where we lose all the valuable experience or information that we can get from these products. So these are, based on my experience, these are the 6 key roadmap events that we should carefully plan in any product or any system that we are developing or going to implement somehow. And ultimately, when you have done this, all this lessons learned part is very weak, including even in defense industry. There are a lot of work needs to be done in this area. People have started to collect a lot of data, but how do you bring it into making a more reliable, or to improve the availability or improve the product? That part is lacking still in the industry. So in the concept phase itself, the first step becomes to defining the reliability requirements. And what I have been doing was, even in the commercial industry, Nokia or in a Sanofi medical devices, trying to set a target for the reliability in the very beginning itself. And what will be the reliability we are looking, what should be the lifetime of that specific product or system, how long it has to last, how long we have to support, how quickly we can bring it up once some problem happens, and what will be the huge conditions. These huge conditions are mostly misunderstood whenever we are developing any product. Recently, we have been looking at some of the fighter planes, and they are going to be used in Saudi Arabia, and there are a certain period of time they will go beyond a specification. And those things are as per the operational profiles, like 25 minutes, they go beyond certain temperature, certain vibrations, depending on the maneuvering of the plane also. So those huge conditions are very critical for any reliability system or product that we are developing. That has to be taken into account. And from the design perspective, whoever does the system design, normally they try to create the product similar to what they have done earlier. And somehow in their unconscious mind, it is that we know how it is used till someone tells them explicitly, no, this is not the right thing. And that's where the reliability engineers and design engineers comes into the conflict during a system development. It takes a lot of effort to explain. So one of the role of the reliability side is to explain what does it mean for the product life. And the challenges that starts is that a different way of creating the reliability requirements. You don't know sometimes that how many units you are going to produce. Then what is my logistics system, reverse logistics system, if something goes wrong, how long it will take to repair. And sometimes some industries, especially in the defense industry, they never give you that what will be the operational time, like how long the system is supposed to be in operations. Is it 2 hours in one time slot, or is it 5 hours, or in a month, how long it will be during the system will be used. So you have to use a lot of your experience or try to do some detective job to figure out what will be those factors. In commercial industry, the warranty, especially in Europe, every electronics product, every electrical products have 2 years of warranty. So that is given. But to bring the customer loyalty, you look beyond the warranty period. You have to build in technical life of the product during that period. And then the challenge becomes also that if there is some target reliability or availability, how do you demonstrate to the customer? And that correlates with the price of the product also. And it's a very delicate balance between whether it is an internal requirement or external requirement that you have got, and then how many challenges you have got, how do you meet those requirements? And there are, in a small pieces, you bring it together to balance those external requirements or internal requirements. It's a quite a good exercise when you start to do a product. I mean, just in a small example, we have in Europe some police helicopters, they want 99% availability. They're spread around the country. But they will not tell us how many units they will buy. So if they buy 10 units, I can have 72 hours to repair those. If they just buy 5 units, it means I don't have any time to repair. So I have to build in reliability in the system. So those are a lot of negotiations. You have to go back to the customer to get clarification exactly how I'm trying to meet my requirements. We have gone through the requirements, then we come to the reliability prediction side. That before the product is ready to test or do anything, we put our efforts in predicting the reliability, and there are various methods of doing that predictions. In defense industry or commercial industry or aviation industry or Airbus, Boeing, all they are very much looking into this parts count method and parts stress methods for the hardware. And then software component reliability side also. And there are some, it is still not a very mature area to calculate these software components reliability. There is some standards, some tools they are trying to implement those things. And then other way you can, people have been trying to do simulations of the operating time or looking at the environment and trying to predict how many failures we can expect. How do you meet the reliability for 100 hours or 20 hours? for the operations. Then ultimately it becomes some of the customers will look at or some of the manufacturers will look at how to do this reliability test for the hardware and software. And this becomes really challenging because when it comes to the parts count method, parts test method, there are many standards. And not all standards cover all the components, all the parts. You need to bring in information from the previous generation of the products and implementing those here to predict those. Then next challenge becomes how do you test the product? Since currently, as we discussed, the products have a very high reliability. If you test it, will not fail. And if you try to make it to fail, then basically you are not stimulating those failure mechanisms that will happen in reality. You have to bring a very delicate balance against what is the in real operations stresses that will come into the product. How do you stimulate, not stimulate those? How do you stimulate those failure mechanisms in the product? So, and sometimes you can spend around 3 to 6 months just to test a small product, demonstrate what we have achieved. So, but slowly the products, the current trend is that people are moving towards to design robustness test, just to show that the design is robust enough, and then you use your previous generation products to argument that there is no weakness in my design, in the current design. But then you need a lot of calculations to be done. You do the temperature model, vibration model, other applications, and you do a lot of simulations to provide that information. But to build the confidence that this product will be reliable enough for 99.9% reliability over 100 hours, or it will last for 10,000 hours or 10 years or 15 years. And then once you have done this requirement and you have done the prediction, then when the design of the product starts or the system you are starting, very commonly used failure mode and effect analysis or failure mode effects and criticality analysis. In the defense industry, this FMECA is quite common. In commercial industry, FMEA is more common to be used. Both serve the same purpose, depending on how do you implement those tools. There is nothing wrong with the tool, but it's the implementation part. That's where you need skills to how to implement those things. Then you carry out this maintainability analysis depending on various factors that influence the maintainability of that product. You get a lot of information from the previous products, previous failures, previous investigations time, and understanding that how much you get the no fault found when someone reported faults, all those aspects. And then the fourth one, that is very current one, this testability analysis, where you want, based on our data collection capability or advancing technology, you want almost 95% of all the faults that are going to happen in the system, we should be able to capture before it happens. Or there should be clear, visible display that which part of the system has failed. What we call it fault isolation. To pinpoint which part of the fault is malfunctioning. And we do a lot of analysis on those parts using the FMECA and FMEA to identify or to display on the dashboard that what is likely to fail or what has already gone wrong. Currently, we are using this emergency services air network for the air ambulance and the police helicopters, where we are collecting around 3,000 different types of testability related parameters, and we are summarizing into simple 10 display so that the police or the ambulance ambulance staff can understand that the aircraft is not worthy, or they have to take a touchdown somewhere nearby. So main challenges in this area, like Amica, all those maintainability or testability, approach-wise, we are very clear. We understand how to do it, but the challenges comes that by design itself, if you don't bring these aspects early in the design, you'll be not able to design in those fault detection of this malfunctioning of any specific circuit or specific component. It's more like condition monitoring online, on time, real-time display. Then we have the isolation is another problem. Like there can be failure. Nature of the fault can come from the two different systems, but they can appear to be the same. But you have to use design-wise in such a way the parameter differs a bit, so that you can say that the fault has come specifically from this. Excuse me. Okay. So, and then the other part, the biggest challenge is, in spite of whatever you do, early times you have the very high rate of the false alerts, false alarm. You might have seen in your fire building, fire alarms. Many times you get the false alarm, false alerts. Those things we need to test. We do a lot of testing before by stressing the product and looking at what type of alerts or is it below 2% false alerts or 1%? Normally, commercial industry they expect up to the 5% you can give as a false alert or false alarm. But the fault detection should be above 95%, and especially for the critical failures that will fail the missions. Like in many fighter planes, they want critical failures should be at least 100% by fault detection. And fault isolation, so you can go up to the 98% or 95%. Yeah, so once you have done the design, run the test, all those things, we launch the product. In spite of whatever you do in the early stage, you are going to have some challenges. You always have a stress exceeding the strength what you have designed in, either due to manufacturing issues or due to suppliers issues or packaging issue, storage issue, handling issue, transport issues. There is always something that comes in because there are so many factors that influence that product. Because currently you have done from the reliability perspective, you have looked into the design of the product. When from the design you are moving into the operational side, if the design margin is not good enough, that's what we do in the reliability prediction. We try to look at the derating side, provide enough design margin in the product, so that if due to some unnatural behavior of the human being or some unwarranted circumstances, the stress exceeds the huge environment that has been stated, we are able to meet those stress by providing extra strength for a limited period of time. So what we do normally that when you start the operations of the product, you keep a core team dedicated for this product itself for a certain period of time, where you do any failures or any dissatisfaction expressed by the customer, that product has to come to the designer's table and have to do thorough failure investigations before you conclude that has this been due to design or manufacturing, or it is supplier related, or is it because of the packaging? And sometimes it takes quite long, but if you provide enough resources, we come to the conclusion very fast, and then we correct those errors also. I mean, in some cases, we took 2 years to fight a battle with a big company. We had to do a legal case against Panasonic, other suppliers, to prove that they were wrong when they supplied us the components. Because what happens during the trial phase, they have a very well managed process to provide those components. But when you go for the mass productions, when you ramp up your production, when you're going into real operations, they ramp up their production also. And that is the time they lose the quality of the product because they bring in new staffs to ramp up their production. So there are some practical issues, especially from Chinese factories. In the beginning, we get a lot of problems. You have to be very careful when you have done the mass production or when you are going to real operations. When you move away from the trials or test to the real life operations, and we should not close down a project immediately. And the challenge that comes is like resources, as I mentioned, and then comes with when do you think that I should stop this? This is always depending on the business strategy. What is the resource requirement and what is the priority, what is the customer's need. Sometimes it goes for 3 months, 6 months. But it's not only finding the fault, it's like implementing those issues or those faults that you have seen and then taking into lessons learned catalog to provide the feedback to the other product, for next generation products. Then next part comes when all the initial issues has been settled down, in fact mortality has gone down, then you come to the normal operations time. And there you measure the reliability, that how we are performing in the field. There the two parameters we use, two metrics we use. I personally recommend two different metrics. Is like a key metrics. Field failure rate is quite well known for all industries. Everyone looks at the failure rate whenever you talk about the reliability during the operations. But we should just remember that this is not a measure of the product reliability. It doesn't tell you the product reliability. It just tells the failure rate based on what is the current populations, based on that. It's not about the reliability of that product. And the more complexity comes because I've seen myself around 10 or 12 different ways of calculating the failure rates. Theory-wise, yeah, the definition is very clear. But when you use the real use, people either use like 10% is the failure rate, like out of 100, if 10 has 1 year, yeah, 10% is the. Then someone else saying, oh no, all the 10 failures were in January itself or in December. January, 20 were in February, or 30 were launched in March, then your failure rate becomes very different. And I have seen, when you do these calculations, we have concluded that its failure rate is increasing, but when you go down into very bottom of the data, when it was put into operation, how many were the power on hours or use hours, you get a very different results. And most of the business, they make their decision based on the failure rates. Or you select our supplier also based on the failure rate of their products. It's very critical, but we need to do in a right way. However, so this is long-term measurement you do, like, but I like this one, this batch failure rate, which gives you the instant indication that how my product is doing or how my system is doing during the launch of this product or operations of this product. Do you calculate in a bit different way? Just you try to catch. It's a similarity wise, like if you're driving from point A to B, if it is 100 kilometers away, and if you're driving at 100 kilometers per hour, so you reach from point A to B in 1 hour time, but just in the first 5 minutes, you may not be driving at a 100 kilometer speed. You may be driving at a 30 kilometer speed, or maybe driving at 70. So this batch failure rate is like instant. At that point of time, how my product is doing, so that you can adjust your quality or reliability of the product. So I find it very useful, and we really found it. Plus, you can correlate your initial demonstration reliability test results also. That if you have seen some errors and if you have ignored those errors, and if you just see one error, see, it magnifies this type of errors quite a lot. It helps you to get the right. And then finally, it comes to the end of life declaration. There is a lot of financial calculations that we have to do based on the reliability to come to end of life. So, in summary or as a conclusion, if you want to have a very reliable product, you need to have a systematic approach starting from the very early phase of the concept. In the concept phase, that's what I am going to do. And from there, the reliability needs just not one person or one department responsibility. It needs help from very different other cross-functional teams, cross-functional disciplines. And implement those methods from the very beginning to achieve a success in a product or system or whatever you have designed, creating a process of system. Thank you. Yeah, that was it of my presentation.
I think, Gautam sir, you'd like to say something on this? Like after this, like Gautam sir is there, we'll be talking about the certificate program, and our Dean Sanjeev Kumar Sharma sir will be talking about for 15 minutes about the Buddha University and what are plans. So that is what we have in plan.
Yes, sir.
Sir, including.
Yeah. So after that we will be just doing the final rounds and question and answers, and the final will be done by Sharma, Dr. Sanjay Sharma. To be good the whole session. The only thing is that we have to follow presentation in minutes. So maybe we have. So what will be the method? There is generally a person, they,
Sir, I had a discussion with Dr. Neeta. Sir, I had a discussion with Dr. Neeta, and she said that on the YouTube, the people can put in their comments and ask questions. So that will be posted on our chat window. She'll copy it on the chat window, and whatever we feel relevant in certain areas, we can take up those questions for discussion. That won't be a problem.
No. I'm talking about to tell the
So your voice is cracked. And it's
system of bell, and you can. Hello. Maybe I'll switch off my. Just a minute. Is it better now?
Yes, sir, it is better.
I have switched off my camera, so I think that is the reason it is now better. So what I'm saying is that we need some help for the speakers. Suppose they are exceeding the time limit, or then somebody has to tell them that okay, now you are approaching the time limit, please wind up. Because on a stage when you are doing, or in the room you are doing, that somebody tells you through some hand signal or something that you are approaching the time limit. So we'll have to think of something. How can we do that? Because in the web seminar, is it possible to do such a kind of thing?
Sir, there is an option of raising the hand or something, but then it is not over here.
No, but raising a hand will be seen by everyone. It must not be seen by anyone else.
Yes, it should not be.
It should be between the speaker and the prompter. You see, there is always a prompter when you are holding some kind of seminar. Then there's a prompter or some, session chairman who will tell the speaker, okay, so who will do that? And how will it be done? That is my question.
So we can prompt in between, like we can say, we have 5 minutes, just before 5 minutes, we have 5 minutes to wind up the discussion.
So maybe you will have to step in and tell the speaker that we have got so much time to wind up.
Actually, for me, it's difficult because everybody's presentation is so nice and so enriching that I don't know, ethically, I don't feel very comfortable with stopping some, but you yourself are so engrossed in the audience, we love to hear, like Chaturvedi sir's presentation was so good.
No, that is also right. That's okay. Then we have to follow also. Because if we don't follow time, audience will they will stop.
So
So maybe ask Dr. Nita. Dr. Nita can give a signal or somebody else give a signal or you can give a signal.
Sir, actually,
Let Dr. Nita give the signal.
sir, in Google Meet there is no option. And
Dr. Vidushi, can I
Sir.
interrupt? Can I interrupt?
yes, for sure. This is now an open discussion for all of us.
I find it once I am sharing my screen, so other screen is not visible. Suppose somebody is, if there is any, say, facility available to interrupt a speaker, but once you are sharing the screen, nothing is coming out visibly. Even if you raise your hand or wave your hand, nothing will come out.
Correct.
Yes.
Right. So there are
Somebody
so
has to
many.
prompt in between.
So
Only thing is somebody has to prompt in between.
Vidushi
the thing
ma'am,
is that it is just like COVID-19. You will have to take care of yourself only.
Yes. So that is the best option. That is what I mean.
Secondly,
We have to make it a social distance.
otherwise, this moderator will have to call the speaker. Please, you are already exceeding your limits. So it is one way
And
communication.
that we were very difficult from the community. Myself, it will not be proper for a kind of
May I suggest?
And just want to
Yes, sir. Please.
I think Professor Dhananjay has very well completed within the time. Professor they have very nicely completed.
Deliver on time.
Only I was exceeding the time. I'll try to. Tonight I'll try to find out.
and Uday sir has also explained some time.
What I'm afraid is that some people may start asking questions in between. How do we mute the mic of everyone? You
Yes,
the present.
Yes, we
Yes,
can do
but
that because I am coordinating, so I can mute everybody's mic.
Right.
So I think you have to
control.
mute everybody's mic. Otherwise, people start asking questions in the between, and then they will disturb the speaker.
We mute everyone except the presenter
Right.
and prompt that his time is approaching. Please make a standard rule that at 20, when the 5 minutes are remaining, you have the mobile number of everyone. Just send the text. Just as a prompt.
Yes.
Oh, beautiful. That is beautiful.
We have this WhatsApp group, we can text over there. So
The thing is that suppose somebody is speaking,
yes.
how he is going to say, I am muting my this WhatsApp messages or SMS calls. Then what will happen? I do not use
No,
this
sir,
notification.
even if you mute,
Sir,
even if you mute,
I can give some suggestions that you can use your own alarm from the mobile to give you a message directly as you think for the COVID.
That is one solution. Yes.
So we can put a timer on our watch, the mobile watch or hand watch, whoever is using which one watch. I don't use a hand watch, so I will use my mobile, and then I can put it like that.
Yeah, when you start presentation, you start the timer
Yes.
on your device.
Yes, sir. Yes,
So
sir.
because interrupting somebody, any of the speakers will the whole way.
Vidushi, interruption, you see, we are not very world-class speakers, right? So interruptions will not look nice. It will be very rude, in my opinion.
That is what I was saying. It will be very difficult for me to interrupt.
The only way of interrupting or any other communication, you should do through the mobile phone, not on the screen.
Correct. Correct.
And
So let everybody keep his timer, and the communication will be done by the mobile phone. Let Dr. Nita be the watch, the watch person for this seminar, because Vidushi, you will also be busy in your presentation and in questions and all that, so you will not be able to do anything.
Fine, sir.
Is it correct? Is that okay?
Fine, sir.
So let Dr. Nita be the watch person of the seminar, and she can signal in the but every person has his or her watch person.
Sure,
What
sir.
should they? What say?
Dr. Nita can look at the timer. In fact, everybody can take up their own timer setting, and we can
Yeah.
all go accordingly. And sir, what I have planned is like I will reduce my presentation to lesser time. Dr. Mishra sir will also, Dr. Rajesh Mishra will also shorten the period of presentation. And in fact, the introduction part can be reduced. So we'll try to cover in that part so that relevant portion is covered within, because every presentation is so informative. So we want to just go through that. Even if we can just rush through the slides, at least the audience know these are the topics which are to be covered. And if we can share the slides with our audience, those who are interested, if they mail to us, only to those people we can just share the slides. If everybody permits me to do that, and there is no copyright.
Let us, Vidushi, let us not share the slides for the.
Okay.
We will one that.
Sir,
Let us do the report and
can we record the session? Can we record the session? I just need a permission from you because it will be
Yes.
on YouTube and it will be recorded over there.
Yes, that Professor Uday Kumar and Professor Chaturvedi, they have to give the permission. Really, I cannot say anything there.
Anuj, I don't have any inhibition for sharing my slides,
Okay.
not the presentation, because we are in education. If it is disseminated,
Yes.
good, and if somebody is pointing out our error, I am accepting it, and we can argue on that. If somebody is saying that you are wrong somewhere, I don't have any hesitation in accepting my errors or transferring whatever I know.
But I will only use these slides if somebody asks for it, because otherwise there are so many audience like today these days, like people join in the webinar only for certificates also. So there may be some people who have just joined it just for the certificate. So I don't want to this presentation to should actually go to the people who are who really wants it, who want to refer it back, and that too on the like the Nanjay sir is in defense. So like I don't think that would be proper. The material or we can cut it.
Vidushi, please take the permission of Professor Uday Kumar, Professor Chaturvedi, Dr. Dhananjay, and Professor that you will be recording their presentation. Just put a message.
Yes, I'll send a mail and
Suppose
whatever
the objects, then
we will not share the presentation. But we will, those who ask for it,
if you share webinar, that is good enough.
video is there for the reference. Why should we give the slide?
Yes, that is what I'm saying. That we will let us know. After that, we have to plan for our certificate course and so we'll use that. Yes.
Okay.
In
So,
fact, what I suspect, the thing is that during presentation, because Many of us are doing projects which are very confidential in nature.
Okay.
So during oration, sometimes it happens automatically, unknowingly we quote that also. So that becomes possibly an issue. If it is recorded in-house, then there could be some editing part involved. So I am only thinking in the direction.
What we can do is, after all this discussion, then I just say you
Yeah.
something like
I was thinking, I mean, it's our responsibility as a presenter to make sure that we don't
Quote anything.
speak on projects in that manner that it becomes breach of the contract regarding
Right.
that's the self-discipline. And then the second can be when you are going to do the presentation there, sharing on the YouTube or wherever, please get it consent from each presenter.
Sure.
Then third thing I was thinking, I know we are doing the presentation, we had some issues. Someone should have all those slides beforehand so that if one of the presenter is not able to share due to some reason, something happened.
I received almost everybody's slide except your slide and Professor's slide. Chaturvedi service is formatting, so he'll be sending me soon. So I'm having the repository. I'll be having the repository of all the slides. So if somebody is not able to present, I can create from my window.
Yeah, that's what I meant.
Sure,
and then we will be monitoring our time on our mobile, but even then, sometimes you may forget. Someone just sends a text that will be good enough through WhatsApp or something.
We'll do that also. In case somebody is able to see that text, we'll do that. I'll add Dr. Meeta also in that group and also share the numbers. So we'll do that. We'll do it parallel. And we will also take a consent bill once the recording is done. We will give you the link of that recording. Only privately the speakers can see it, and if they feel they're okay with that part and no editing is required, we will post it as such. Otherwise, we will cut the part which is not to be shown to the put on the web. That we can do. We make sure of all these things.
Yeah, that's good. And then another thing I was thinking, is it possible to upload the slides beforehand? Like someone has uploaded it, and then whenever the presenter turns comes, it takes over from that part of the slide. In that way,
That's
you
a very good idea. That's a very good
much time.
It's a very good idea. I will share my slides on the WhatsApp forum, and let us share in the one forum itself.
Sir, I share the folder with the presentation slides, but then that means we are giving the slides to the audience.
No, not audience. I'm saying in our WhatsApp group we will share our slides.
I mean,
It will get the point.
Sir, what I'll do is I'll keep all the slides with me, and giving it to audience should not be the thing, because if you upload it for the audience, it will be wrong.
You see, please try to understand what we are saying is that suppose able to run the slide, then you can run it from one base and he only from the other. That we are saying.
exactly. That's what I meant.
Yes, sir. That I'll do. You can all mail me your slides,
You see,
and I'll keep it repository.
we are all reliability people, so we will keep a backup. You see, Dr. Dhananjay Kumar is a reliable, so he's talking about reliability of the presentation right now.
Yes, sir. That's what I was trying to do.
So,
Having a backup system.
Right there. In case somebody is not able to run slides to his computer, then you can run them and he can just speak. We do many times like this, you know.
Sure, sir.
You should get the point.
Yes, sir. I'll do that. In fact, Dr. Neeta was discussing that only, and she also suggested that you should have all the slides. That is why I had sent a mail for getting all the slides. Right? Why repository of that? I think by 23rd we can have all the slides, final slides with me, or 24th, so that I keep final
23rd,
shape.
let us last date in fact.
Fine.
Sanjay sir, we couldn't hear you.
I think
Let 23rd be the last date for the slide. This is what I am only saying right now.
fine, sir. Fine, sir. Fine, sir. So can we
Okay, so
continue?
let us thank everyone, all the esteemed speakers, Professor Uday Kumar, Professor Chaturvedi, Dr. Dhananjay Kumar, and Vidushi, and Dr. Sanjay Sharma, and Dr. Rajesh Mishra, and Dr. Neeta. We let us thank everyone for their time today on a Sunday and a holiday to have met here, and we will meet on 25th. But we must have all the presentations in one place, and I think on 23rd you will send the link for the presentation. So I'm sure God will help us, and this is a very noble cause that we are trying to do. And subsequent to that, also we will continue with our certificate program and master's 2-year online master's program in PHM and RAEMS. There is no such course in the world today as of now, and it will give us a very good value to not only India, to the rest of the world. So thanks a lot, sir. Thanks a lot.
अंदर जी खाना कहाँ खिलाओगे ये भी तो बता दो.
वर्चुअली हो सकता है सर, इसमें तो वर्चुअल खाना खिला सकते हैं सर.
वर्चुअल टी वर्चुअल बहुत सस्ते में निपटा रहे हो हमको.
सर आजकल वर्चुअल लाइफ ही हो गया है.
It's a really Herculean effort. I really appreciate that so many people have involved in this, and we'll definitely look forward to have many more such type of activities. In fact, we always say that our center or our school is the only center in this country. But because of your efforts and your team efforts, something is coming up at least in near or around Delhi or in UP. Thank you very much.
Thank you so much,
So
sir. Thank you.
you have to guide us all through this journey, because we cannot do without you.
No, Dr. Vidushi, definitely, whatever we can support entire school on the behalf of entire school, I can assure you that whatever you need from our side, we will definitely extend.
Thank you so much, sir.
Thank you for the opportunity.
Thank you, sir.
Thank you, sir. Thank you.
Okay.